Hello, this is Mike Lawless, and in this video I'll discuss converting in vitro permeability data to effective jejunum permeability. I will be going through GastroPlus tutorial 5.3.3 to illustrate this process. If you have the ADME predictor module in GastroPlus, the effective human jejunal permeability can be predicted by ADME predictor when you import the compounds. GastroPlus can also convert between dog, rat, and human PEF. So if you have measured the PEF for a dog, for example, GastroPlus contains a correlation which would convert that into human. And typically what we see is that the PEF for a dog is higher than that of a human, and human PEF is typically higher than that for a rat. The main emphasis of this video will be estimating PEF from in vitro experiments. For example, let's say you have measured data from CACO2, MDCK, PAPA, or animal tissue experiments, and you want to convert those values into PEF in GastroPlus. Let's take a look at the effective permeability section in the GastroPlus interface. I imported this compound using ADME predictor to perform various predictions of the physicochemical properties, and it's predicted 3.26 for the human PEF value. So all that's very fine and very straightforward if you simply use the ADME, if you have the ADME predictor module and you use it to predict these values. Now let's say you had done an experiment on this drug in rat and had come up with a PEF in rat of for a value of 2 times 10 to the minus 4 centimeters per second. So you would enter that value here, and then the source would be rat. And so you measured it at 2. It's used a conversion. GastroPlus has used a conversion to convert that rat PEF into human PEF, and given it a value of 8.8 centimeters per times 10 to the minus 4 centimeters per second. Now let's take a look and let's say you wanted the PEF for a dog. You were going to do simulations for dog physiology. You could go into the physiology tab and change the physiology to a fasted beagle. And then once we go back into the compound tab, you'll see that the PEF now is associated with dog, and it's 24.5 times 10 to the minus 4 centimeters per second. So that kind of illustrates that PEF for a compound in a mouse, in a rat would be 2. The human was 8.8, and then for a dog it's 24. So that gives you the order that dog permeability is typically higher than human, typically higher than rat. In this section of the video, I'll discuss creating a correlation between your in vitro CACO2 data and in vivo human permeability. This slide illustrates the steps involved in creating the correlation. So let's say your experimental group measures in vitro CACO2 permeability as a standard experiment for your development compounds. They will have to measure the CACO2 in your own experiment for a few standard BCS compounds, and we typically recommend at least 10 standards, and that you kind of span the range from low permeability to high permeability. These values will be then entered into the permeability converter in GastroPlus. GastroPlus will then create various correlations of your data with human PEF, so it'll create 3 types of correlation: a linear, log linear, and a power correlation. You'll choose one of these correlations, export it, and then it will be saved in GastroPlus and saved as a source on the drop-down menu. Once you've created this correlation between your in vitro CACO2 experiment, you can take an arbitrary compound, measure the CACO2 permeability, import the compound into GastroPlus, and then use this converter to convert it to human PEF, and then perform your simulation. This slide contains CACO2 permeability data from a publication by Ju et al. And these are some of the standards for the BCS, and we've have experimental measurements of this from one of our collaborators. And so we'll input this data into GastroPlus and then create a correlation between this CACO2 data and human PEF. To enter the CACO2 data into GastroPlus, we need to switch the source to user. This will make this button available, Convert from User Data. We'll simply click on it and then open up a file called Sample UDP that's in User Public Simulations Plus GastroPlus 9.0. And the first time we open it, it's going to say there's not enough points to perform the correlation. That's normal because all of them will be 0 in this file. We simply click OK and start entering data. So when you want to enter the data, I start with the amoxicillin here. If you double click on that, it will delete the current entry, and then you simply enter the value from the journal article in this case. Now we don't need to specify the exponent, which is 10 to the minus 5 from this journal article. It won't matter in the correlation. So I'll just go ahead and enter one more and then do this kind of offline. Now I've entered all the data, and I simply click the Solve button to create the correlation. And you'll see that it shows the correlation with the lowest Aki coefficient, which is the log linear plot, or correlation, and gives some of the statistics and then the equation for the transformation here. So we'll go ahead and we're going to save this as a file in there, and it'll just be called my CACO data, in case we want to bring that up later and maybe add more structures to it. Now we want to export this correlation, so we go down to File, Export Conversion, and this is limited to 5 characters, so we'll call it CHU CA for CACO2. Click OK, and then we need to enter a label for the PEF box. CACO2 PAP is a good one, and it also has the units here. So we'll again click OK, and then OK to dismiss the dialog box. And now you'll see that the Ka has been selected as the effective permeability. Now if we imported this compound, and let's say our measured PEF was 2, it would use this correlation to convert the CACO2 permeability to PEF permeability in human. We can further look at the file that defines this, and it's in the GastroPlus tree. So I'll bring up this simple editor and then open a file. You have to change this to all files and then this PEF conversion. So you'll see that this new entry was added to that file, and that's what defines it in GastroPlus. And that completes the process for converting your CACO2 data into human PEF. Thank you for your attention, and if you have any questions, just please send me an email at mlawless@simulations-plus.com.